Okay, so next I have here is 2014 question 6. So I'm actually going to do the whole of this question. Okay, so the fuel and camping gas cylinders, like the one pictured on the right, is a liquefied mixture of propane, butane and another compound, which is a structural isomer. Name the homologous series to which propane and butane belong. Alkanes. Okay, and then you're asked to draw the structural formula of propes. Propane, 3 carbons, meth, eth, prop, all with single bonds, and 3 hydrogens coming out of the first and end, last carbon, and 2 out of the middle. B. Propane and butane have boiling points of 42.1 and 0.5 degrees Celsius respectively. Explain why propane has a lower boiling point. So they're both here going to have the same type of intermolecular forces. So it's not going to be that they're both van der Waals. Okay. So the reason why, remember, your boiling point is dependent on 2 things. The first one is the types of intermolecular force. Okay, which is divided up into my 3 van der Waals, my dipole-dipole, and my hydrogen bonds. Okay, now both of these belong to the same family, so they all have the same types of intermolecular bonds, so it can't be this. So the second thing is that the relative molecular mass. Okay, so that is the reason why my boiling point of butane is going to be greater. Okay, so relative molecular mass of propane is smaller, and because of that it has a lower boiling point. Okay, and remember there you're asked to explain why propane has a lower boiling point, so you have to explain propane has a lower or smaller relative molecular mass. Okay, part C. What is meant by saying that compounds are structural isomers? Okay, so they are compounds of the same molecular formula, but different structural formulas and then you should write down hence different properties. Okay. Draw the structural formula of the isomer of butane. Okay. First thing to note is that a structural isomer is itself in its normal structure. So that is one structural isomer. Okay. And then my second structural isomer is I cut off my CH3 here and it attaches onto my second carbon here, and that is 2-methyl propane. You're only asked to draw, so you wouldn't get your marks. They are the only 2 acceptable answers. Okay, so that is your structural formula. Next then, you're asked to define your heat of combustion, and it is the heat change, and you have to state when 1 mole of a substance, so you have to have 1 mole of a substance, is burned, and you have to have completely in excess oxygen. Okay, so very particular there. Next then, we're asked, write the balanced equation for the complete combustion of my butane. Okay, so my complete combustion of butane. So I have my formula, okay, and if I look here, butane 1, 2, 3, 4, C4, 2, 4, 6, 8, 10, okay, so H10. So C4, H10, complete combustion, burns an oxygen to produce carbon dioxide and water. Okay, so I'm asked to write the balanced equation. 4 carbons here, 4 carbons on my right hand side. 10 hydrogens here, there needs to be 10 hydrogens, 5 by 2 is 10. And if I look here, 4 by 2, I have 8 oxygens plus 5 oxygens. Okay, so in total, that gives me 13 O's. So I need to have 13 over here. Okay, so if I look here, what by 2 will give me 13, 6.5. That's my balanced equation. Then you're asked to calculate the heat of combustion. So I'm looking here for my delta H value. And I'm told that the heat of carbon dioxide and butane, C4H10, and I'm missing one, sorry, water is in the middle there, are minus 393.5, minus 285.8, and minus 125.7. Okay, so based on that, carbon plus O2, C plus O2. Hydrogen, H2, plus a half O2. Okay, gas is always in molecules. 4 carbons plus 5 H2. And what we do now is we compare to what we see up here. Carbon dioxide, 4 of them. So I need to multiply this by 4. 4C plus 4O2 goes to 4CO2. Okay, so then I have minus 393.5 multiplied by 4 gives me minus 1574. Okay, next here, H2O on the right hand side, but I need 5 of them. So 5H2 plus 5 over 2 O2 goes to 5H2O. So that is 285.8 minus multiplied by 5 gives me minus 1429. And finally then, if I look at this C4H10, it appears on my right hand side here, left hand side here, so I have to reverse this equation. So C4H10 goes to 4C plus 5H2, and I reverse it, so plus 125.7. And then I compare what I have on my left hand side and right hand side. Anything that appears on both cancels. So there you go. 5H2 on my left hand side, 5H2 on my right hand side. Okay, that's it. So I have C4H10 plus, and I have 4. Okay, 5 over 2, I can write that as 2.5. So that's 6.5 O2 goes to 4CO2 plus 5H2O. And if I look, that's what I have up here. So my delta H value minus 1574 minus 1429 plus 125.7 gives me an answer of minus 2877.3 kilojoules per mole.